All right, hello, lots of people. 9-2 notes today. This is kind of a short section. I like chapter 9. I don't know how you guys liked in section 9-1, like circles and circumference, but I like chapter 9. The circles, like that's my vibe right there. I got it. Okay. Take a look at this example over here off to the side. I'm going to label some things. Okay. We have like this circle on the outside centered at B, and then we're going to like put an angle inside of it, okay? This angle is called a central angle because it's in the center. We'll eventually be doing with angles that like do stuff like this that go all the way across, but not today. This is called a central angle because the vertex is in the center, okay? And then we can talk about like the measure of this angle, right? Okay, so if we're talking about angles inside of a circle, how many degrees is inside of a whole circle? You know, 360, right? If you like spin around, it's 360 degrees. How many degrees do you think this guy is? Like it looks like it's more than 90 degrees. It's like a third of the circle, probably. So shall we say 120 degrees? That would be a third, right? Okay. This morning they said 105. I think maybe I'd go with you guys by saying that it's a third of the circle, right? Like the other third, like if I separate it, would be like there. I buy that. Let's go 120. I like that better. Okay, then, so we have angles. This would be like angle ABC is how we would name it, right? That's angle ABC, and that is 120 degrees, we say, right? Okay, then we have stuff that's called arcs, right? So an arc is labeled by, let's go AC. Arc AC, and it has like a little arch over top of it, like a little half circle. And so if we're talking about arch AC or arc AC, it's like this guy right here. Does that make sense? We're talking about like the portion of the circle that is cut out by like that slice of pizza. It's like the pizza crust, right? Okay, now here's the deal. This is kind of the confusing part. There are two different ways of measuring an arc. You can tell me what the degree measure is, or you can tell me what the length of it is. I can't spell length. Length. So there's two different measurements, and so you have to pay attention and be very careful on your homework assignment which one they're asking for. If they're asking for the measure of it, they're asking for the degree. If they're asking for the length, they will say length, okay? So if I'm looking at this thing right here and I'm trying to figure out how many degrees that is, the very nice thing is that whatever this degree measure is for the central angle, it's going to be the same as the degree measure for the arc. So AC will be 120 degrees, just like that central angle is. Does that make sense? Yeah? Okay. And then if we start talking about the length of the arc, we have to know like the radius, and we'll get to that stuff, okay? But like the length would be if I would to like step on here and walk all the way around, like how long would that be, okay? That we'll get to. That's like the second half of this lesson. But for right now, let's just deal with degrees. So the degree of the arc will be the same as the degree of the angle in the center. Good? Okay. These guys right here, they have these labeled, and rather than doing like ABC, they have like angle 1 is this guy, angle 2 is this guy, angle 3 is this guy. And we know that all three of them should add up to be 360 degrees. So if they give me two of them, I can figure out the third one, right? Yeah. Okay, so that's what they're going to do for this example. They're having us find the measure of angle X, which is that center angle, okay? So how can we do that? 130, and then this is a box, so that's 90 degrees, right? 130 plus 90 is 220, and then we subtract that from 360. So 360 minus 220 is like 140. So X is 140 degrees. That's what this is right here. Yeah, not too bad. Pretty easy. Yeah? Okay, now I'm going to talk about this picture real quick because technically, when we're talking about arcs, like if this is my angle that's in the center, we technically have an arc here and we have an arc around the backside. It's not just necessarily that we have the shorter one, right? So the confusing part is if I say arc PR, like that's the notation that I would use. Am I talking about this arc PR, or am I talking about the backwards arc PR? Good question. Technically, both of those are correct. Okay, so what they will do is to unconfuse you. A lot of times what they will do is they'll strap another point on here. Let's call this S. And if they do that and they would say arc PR, they're talking about this arc PR. If they're talking about the bottom half, they would call it arc PSR. and use 3 letters. And that shows you that we're talking about that backside. Does that make sense? So usually if they're talking about the larger portion, they'll put another point on there and name it with 3 letters. Does that make sense? Okay, so let's go down for this example, and they have the 3 little things in this box, and I'm going to go through this. We have stuff that's called a minor arc, so I'm going to label this off to the side. We have major arcs, and we have semicircles, and this is a really easy concept, so this is going to be like the easy part. Circle. Okay, a minor arc is an arc that is less than half of a circle. Okay, how many degrees is half of a circle? Any ideas? How many degrees is a full circle? 360. So how many degrees is a half a circle? What? 180. 180. So a minor arc is any arc that's less than half a circle or any arc that's less than 180 degrees, because that's what half is, right? A major arc, if you can see in this diagram right here, they've outlined that bottom half, right? And that is going to be greater than half the circle, which means greater than 180 degrees. Okay, that's labeled a major arc. So minor arc is less than half, major arc is greater than half, right? It's kind of easy to see. And then a semicircle is exactly half the circle, right? Or equal to 180 degrees. So you can see like this guy right here, this would be exactly 180 degrees right there. Okay, pretty easy concept, not too bad. Okay, they're going to have us do some labeling in the next example, but I'll give you a second to write that down. Okay, good? Happy with that? All right, let's do some ABC. Here we go. A is the measure, so they tell us that GJ is the diameter of this circle. So this guy right here is the full, like halfway across, right? Going through the center, which is K. And then it says, identify each one of these ABC as a major, minor, or semicircle and find its measure. And when they say measure, they're asking for the degree measure, okay? So a major arc, minor arc, or semicircle, they're asking first for the measure of GH. That's what the little M stands for in the front, measure of GH, okay? So we're talking about arc GH, okay? Now, I'm guessing that when they say GH, they're talking about this one, right? Not this one around the backside here, because then they would put 3 letters in it, right? They would call it like GLH or something like that. So we're talking about GH here. What is his measure? 122, exactly how it's labeled, right? 122 degrees, and that is a major, minor, or semicircle. Which one?
That is a minor.
A minor. Now it gets kind of confusing because it's an obtuse angle, but don't think obtuse angle. Half a circle or less than half a circle. So that's a minor arc. All right, the next one, they ask for GLH. So there is my 3 letters, right? GLH is going to this direction. So it's asking me for this chunk. Okay, how do I find out how many degrees that is?
120 minus 360.
360 minus 120. Yep.
122.
Or 122, I mean. Yep. Like 238, I think.
Yep.
Is that right? Yep. So that's like this little piece right here. 238 degrees, major, minor, semicircle? Major. Not too bad. This is like the easy part, right? Okay. No. Did you say no? Oh, you said yes. Okay. I think you said no. Like, okay, whatever, maybe. GLJ is the last one. GLJ, how many degrees? 180, and that is a semicircle. This is like, give us all of these, right? Like, make the whole test this, right? Awesome. Okay, good. Backside, here we go. All right. There is a typo right here, a little C. I don't need to have a little C there. I don't know why. I don't know. There's only 2 examples. So we have a pie chart, but take a look at the things that are labeled on the pie chart. These are talking about like participation in these extracurricular activities, so like soccer and volleyball and whatever. The biggest category is basketball with 20%. That's not degrees, because percentages are out of 100, degrees are out of 360, so it's a little bit of a tricky thing. All right, they're asking us to refer to the circle graph and find each measure. So they want to know the measure of arc CD, and CD is the volleyball chunk, okay? And CD is 18%, but that doesn't mean 18 degrees. How do I figure out how many degrees that is?
That's a good question.
Yeah.
18% of 360.
18% of 360. So how do I do that as a calculation? 18% of 360. 360 times 0.18, right? 18% is the decimals, 0.18. So I just take 18% of 360. 64.8 degrees is how many that is, right? Like that angle is a 64.8 degree angle. That seems about right. 64 degrees. Not too bad. Okay. Then the next one, B says the measure of arc BC, which is track and field. Do you see arc BC? Isn't it the same? They're both 18 degrees. So don't do it twice. 64.8 degrees. Very nice. Good? Happy with that? Yeah, not too bad. Okay, so just be careful when they say percentages versus degrees. You'll have to convert, okay? All right, now, all of that stuff was the easy part. No. This is still an easy part. Example 4 is easy. Example 5 is just the, like, slightly more difficult part, okay? So example 4, find each measure, and they want us to find the measure of arc AED.
90 plus 63.
AED, yeah. So that's a little 90-degree angle, and then 63 degrees. So we add them together, 90 and 63, and that is 153 degrees. Jake's like, I am all over this. Love it. Okay, now this one's a little bit harder, though. This one is ADB.
You'd add 153
ADB.
153.
plus 90.
So you're saying this is 153, right?
Yeah.
And then we have to add this to it. How much is that?
243.
Oh, that's
Yeah.
90, right?
Yeah, because it's.
Does it have to be 90? Yeah, because this is a straight line, right? So if this is 90, then this is 90, right?
Mhm.
Okay. Or this is what they said this morning. They said, okay, this is a straight line. So this right here is 180, right? That's what Jayton said this morning. And 63 is there. So if you add those together, still get 243. So it doesn't matter how you add it, as long as you use the right numbers, you'll get 243. Make sense? Yeah? So however you chunk it, just make sure that you're doing the right numbers, right? Okay, cool? That's not too bad, right? All right.
There's 2 example 5.
Ready? There's 2 example 5s. Yep. And this is the like slightly harder part, but I don't think it's really, is it really that hard? No?
What part is it?
This is like finding the length. We're using the radius and stuff. I don't think it's really that hard. Okay, so here's what I want you to write. Everything from here and up was finding arcs by degree. Okay, I told you that there was 2 different ways of measuring an arc. Everything up above, we were measuring arcs by degree. Okay, example 5 is measuring an arc by the length of it. So like if I were actually going to walk like around that part or find the crust of the pizza, that's what the length would be. Okay, that's what we're trying to find. So not looking at degree, well, we still look at the degree, but we're actually having to do something with that degree and find the length of the arc. Okay, so slightly harder, still not too bad. Okay, here we go. So A, they're having us find the length of ZY. So we know that that's 75 degrees. Like that chunk is 75 degrees. But how long is that actually? Like how long would that pizza crust be? Like in inches, how many inches would that pizza crust be? That's what we have to decide. So slightly more difficult, okay? When we're finding this little chunk right here, like this little piece, that's part of the circumference, right? Okay? And circumference of a circle is diameter times pi. So let's like find like what the whole circumference would be. What's the diameter of this circle going to be? 8. So the entire circumference is 8 pi, whatever that would be, right? You don't have to calculate it out. But 8 pi would be the distance if I was doing all the way around it, right? That would be like the entire crust. 8 pi inches would be all the way around. Except I only want like this chunk of it. And we look at like this chunk as a fraction of the circle, right? It's 75 degrees out of how much? 360. So as a fraction of the circle, that chunk is only 75 degrees out of 360. And all I do is multiply those together. So I take the entire circumference times the fraction that I have. And then, and the way that you do this, you can literally type into your calculator 8 pi times 75 divided by 360 if you want to do it that way. And it should give you a decimal, I think. 5.24 inches is how long that crust is. Okay? All right, now I'm going to go back to, before we move on, I'm going to go back to the original problem. They're telling me that the radius is 4 inches. So this length from here to here is 4 inches. Okay? And look at what we're trying to find. We're trying to find the distance here. And I realize that it's like curved, So it might be a little larger, but would it make sense for me to say that this is 8.24 inches? Probably. It's probably just slightly more than 4, right? If you're like looking at this length versus this one, they look about the same. Maybe the arched one is a slightly more. So I would buy that that's 5.24 inches. Make sense? Okay. I probably would not buy that that's like 15 inches. So going back and looking at the diagram, like to see if your answer makes sense, that's a really good idea. Okay, let's do B. B is asking for ZY again. We know the degree measure is 130, but they're not asking for a degree measure. They're asking for like, how long is this exactly? So let's take a guesstimation. Let's do that first. This is 10 centimeters all the way across here. How long do you think this is in relationship to 10? If you had to guess. You think a little bit smaller? Yeah, maybe. Or maybe like right around 10. It could be right around 10. Because this looks smaller right here, but it's curved. So maybe if we lengthened it out, it would be about 10. I don't know. We're going to find out. Okay? But we have a guesstimation. Like we know like it should be maybe around 10, maybe slightly smaller. Whatever, than 10. Okay. So if I were to find the entire circumference, I would take the diameter times pi. They're giving me the diameter, which is 10 pi. But I don't want the whole circle. I only want a fraction of it. What fraction? 130 out of 360. Now you can knock the zeros off if you want and just take it times 13 over 36 if you want to do less stuff on your calculator. But you can take 10 pi times 13 divided by 36 and you get like something. What'd you get? 11.34. So it is bigger than 10. So if we stretch this out, this part right here, if we stretch it out and make it a length, it would be just slightly more than 10, okay? But that would make sense though, right? Like I'm guessing that probably wouldn't be like 1 centimeter, or I'm guessing maybe like 20 centimeters would be too big, okay? But 11.34, that makes sense, all right? So if you need a formula for how to find these arc lengths, write this down off to the side over here. The arc length, to find arc length, we take the entire circumference. The entire circumference, and then we take that times the fraction of the circle that we want, right? Like 130 out of 360 or whatever. So we take the circumference. If you need to write the formula for circumference, it's diameter times pi, and then times the fraction of the circle that we want. So something over 360. Whatever degrees we have over 360. That's how you find the length of the arc. Does that make sense?
Yes.
Yeah, not too bad. Okay, don't shoot me. Chase decided. Sorry. He's like, I already have 1 through 14 done. What?
Can we just decide for ourselves?
Oh, we skipped number 5, if you're watching the video. I told them that, but I didn't tell you that. 9.2, skills practice. Do 1 through 14.
Great.
Yeah. And then on the back side, so you don't have to do this bottom part. And then on the back side, just do 13 through 17. Now 17 is not hard, it's just the percentages. So it's, for part A, it's having you convert these to degrees. And if you want to not have to like rewrite all the categories over here, you can list them off to the side over here, the degree measures. Does that make sense? You see what I'm saying? Okay, so if you want to just list your percentages right next to your degree, or your list your degrees right next to your percentages, you can just put the column over here. Okay, good? Happy with that? It's not too hard of a story problem, actually. Okay, so Chase chose, sorry, shoot him, not me. No, well, don't, anyway. So, I did not just say shoot a student. Sorry, that's not what I mean. Quit twisting my words. All right, anyway. Hey, goodbye people in the video.